How do you find the probability of an event? Now, this is something that you guys have seen almost every year in the math class. It's very important that teachers go over this. And probably one of the most famous problems is the marble problem. You guys remember the marble problem? Yeah. Yeah, it says something like, there is a bag that contains 4 red marbles, 2 blue marbles, and 6 green marbles. Find the probability of... And it tells you something. And you have to find the probability of a certain event happening, like getting 1 blue, or getting 1 green, or something like that. Getting 1 blue or 1 green. But this is the formula to find the probability of an event. P stands for probability. You got your event. Probability of this event is the number of outcomes you want on top, and then on bottom is the total number of possible outcomes. So this is the total possible, and the top represents the number that you want, and that's important. So what I want for you guys to do right now is I want you guys to try to do these problems so far. Okay, it's up there. So it's the same problem. Okay, the same like beginning part, same context, and I'm asking you to find the probability of each of these events. And there's 1, 2, 3, 4, 5, 6, 7. 7? 1, 2, 3, 4, 5, 6, 7. Yes. Okay. So if you're watching the video, press pause. Try to do them on your own before I do them. Okay, let's talk about these. There's a couple of things that you guys need to remember, recall, or know in order to do these. And one of them, you need to know what the difference is between and, which is normally denoted by an intersection symbol. It looks like an upside down U. And what's the difference between that and, I'm sorry, I'm not making sense with my words, and or. If ever you have an and, then you know that you're going to add. I'm sorry, not add. You're going to multiply. Whenever you have an or, you know that you're going to add. This symbol right here means intersection, so it means both of them have to occur. And this one means or. It means union. And so that means either this one can happen or this one can happen. So whenever you see either, you got to think or whenever you see union. You have to know that. You have to know the difference between replacement and without replacement. This is whenever you have two events happening. Sometimes one event affects the outcome of the other event, and sometimes they don't. You also need to know what when order matters versus when order doesn't matter. Alright, let's take a look at an example right here. Let's take a look at this first one. This is as basic as it gets. The first one says choosing 1 red marble. So when choosing 1 red marble, how many total possibilities are there? Let's figure out the bottom number first. How many total possibilities are there for choosing 1 marble? There's 12 total marbles. There's 4 right there, 2, and then 6. So that makes a total of 12 possibilities, 12 total outcomes. And how many of those outcomes do we want? There's 4 of them. And so all you have to do is you have to simplify this. So you divide the top and bottom by 4. You get 1 over 3. And that's your answer for the first one. The second one, it says choosing 1 red marble or 1 green marble. Now whenever you guys see or, what do you guys think? Addition. Okay, so I see or, so I'm thinking add. And so we have to do the probability of choosing 1 red, which before we knew it was 12 total possibilities, and there's only 4 reds. And so that's the probability of choosing 1 red. And then the probability of choosing 1 green would be, well, there's still 12 possibilities. How many total outcomes do we want, to go up here? How many green marbles are there? Yeah, there's 6. Okay, so we add those two together, we get 10 over 12, and we just simplify that dude to get 5 over 6. And that's your probability for the second one, for the letter B. Now let's look at letter C. This one says choosing one red marble and put it back, so it's with replacement, and then you choose a green marble. See the word and? That changes the problem. Before we saw the word or and we had to add, but when we see and, we think what? Multiply. Okay, you got to think of multiplication when you see the word and. So we do the first one, the probability of choosing one red, which is 1, no, not 1. How many total reds are there? Oh yeah, 4, and then 12 total possibilities of choosing one marble. And then we put it back. Okay, that's important. We put it back because we're going to multiply it to the next probability. The next probability, how many total possibilities are there? If the marble's put back, it's still 12. And there's how many total greens? There's 6 total greens. Then we just have to multiply those straight across. First going to simplify these. That becomes 1, this becomes 3, that becomes 1, this becomes 2. And so we get 1 over 6. So 1 over 6 is your probability for getting one red marble and then putting it back and then one green marble. Finally, the last one for this page says choosing one red marble and then one green marble. So it's kind of like the same as this one, except what's the difference between C and D? You don't put it back. There's no replacement for this one. You're choosing one red and then you're choosing one green. So let's see how that affects our logic. Let's see. We do one red marble, and that's, what is it, 4 over 12, right? And you could write the simplified version. You don't have to write that. And then we see the word and that we know that's multiply. We're going to multiply that to finding one green marble. Okay, well, how many total possibilities are there now after I've taken one marble out? Yeah, now there's 11. So actually went down. This is the first time we're seeing it go down, the number of possibilities, the total possibilities. And how many total outcomes do we want go on top? It's 6 because there's 6 green. Okay, so now you just have to multiply those straight across. I'm going to go ahead and simplify this to say 1 over 3. Simplify the 3 and the 6, cross-canceling. Everybody loves cross-canceling. You get 2 over 11. And that's your probability for that one. Now, here's where things really change. You guys haven't done these ones. This one says you're choosing one red marble and one green marble. Does order matter here? Before, it said choosing one red and then one green. And so the order mattered. And then? No and then. Nobody? Okay, never mind. All right, so we're choosing one red marble and then, no, not and then, and no and then. Never mind. Okay, and one green marble. You guys will know where that's from? All right, never mind. Okay, so order does not matter. Remember that. Order does not matter. So normally you would do, like we were doing like 12 and then 1, right? Because it goes down 1. But if we, or I'm sorry, 12 and then 11. But this means order matters. We have to say that order does not matter. And so we can't do 12 over 11. Instead, what we're going to do is we're going to start with our fraction bar. And on the bottom, we're going to put the total number of possibilities, right? Total number of possible outcomes on the bottom. So how many different ways can we choose 1, 2 marbles? And how are we going to figure that out? Well, we use a combination. We're going to choose 2 out of 12. Will that tell us the total number of outcomes? Not in, and saying that order doesn't matter? It will, won't it? Yes, it will. Yes, very much. And then on the top, we're going to write how many total possible ways we can choose a red, and we're going to multiply that by how many total possible ways we can choose a green, because and means multiply. And so that's 4 for the red times 6 for the green. And you could say 4 choose 1. You could say 4 choose 1 times 6 choose 1, but that's just 4 and 6. It's just, it looks kind of neat when they're all choose numbers. It's like, oh, okay. So the top you're going to get 24. On the bottom you're going to go 12 choose 2. What do you guys get? Okay, we got 66 for that one. And then once you punch that into your calculator, what does it simplify down to? 4/11. Okay, so there's your probability right there for letter E. And then we have the last one. Again, it says, well, not again, but again, order doesn't matter here. It says choosing 4 marbles, 1 red marble, and 3 green. Does order matter? It doesn't say and then. No and then. I'm just cracking up in my head about that. Sorry, guys. Okay, so we get started with our fraction bar. We put the total number on the bottom, total number possible. How many are we choosing total? We're choosing 4. So how many different ways can we choose 4 marbles? Well, we got to put the total amount of choices right there is 12. There's a total amount of 12 choices. We're making 4 choices. This will give us a total number of outcomes for, choosing 4 marbles. And on the top, we're going to have to do one combination for the red times one combination for the green. So we're going to do, we're choosing 1 red, and there's 4 possible choices for the red, and we're going to multiply that times, we're choosing 3 green. How many total possible choices for the green? 6, right? Yeah, 6 right there. Okay. On the bottom, what do we get for the bottom? Okay, we got 495. And then we know that 4 choose 1 is 4, and we're going to multiply it times 6 choose 3, which is 20. So we have 80 up top, 495 on the bottom, and that's going to simplify to what? All right, it's 16/99. Ooh, that's an ugly probability. But the correct probability, when order doesn't matter, you better count on using their combinations. All right. Now there's one more situation. I say this one for last because this one is by far the most difficult to understand. Okay. You guys ready for this action? 1 card is selected from a standard deck of 52 playing cards. Not 1 card. Dang it. I need to fix that. If you were drawing 2 cards. Okay, I'll fix that right now because it's bugging. Okay, 2 cards. 2 cards are selected from a standard deck of 52 playing cards. If you were drawing 2 cards, what is the probability of both being a king or a black card? Okay, so let's start out the part that's not so hard to understand. Let's do the bottom part. How many total possibilities are there? Well, how many cards are we choosing? There's 52 choices, right? And how many cards are we choosing? We're choosing 2. Okay, so the bottom's done. That's how many total possibilities, total outcomes there are. On the top, that's the other story. We have to look at both being a king, or that's a plus, both being a black card. Okay, so let's think about kings. How many kings are there? Okay, so we're going to choose, how many out of the 4? Just choose 2. Okay, and then we're going to add, that's for the kings, that's if they're both kings. And we're going to add how many ways we can choose a black card. Now we're choosing 2 black cards, right? How many total black cards are there? 26. Okay, and then we're almost done. Like that doesn't look too bad, but this is the part that's like, what? You ready for this? What outcome is counted twice? Think about it. This one counts all the times you can have 2 kings. This one counts all the times you get 2 blacks. Is there an outcome that's repeated in both of these? Yeah, 2 black kings. We can have, a king of spades and a king of clubs. Remember, order doesn't matter, so it doesn't matter which one I write first. But this counts as one outcome. It's one outcome out of all these. Actually, and this outcome is counted in here and in here, right? Because it's going to be counted in the black cards too, right? So we have to take one of those outcomes out because we want it to be counted, but we don't want it to be counted both times. So you just go -1. Right. Okay, what is 4 choose 2? What's 4 choose 2? Come on, what does 4 choose 2? 6. So you have 6 plus, can you guys do 26 choose 2? 325, and then we're going to subtract 1 from that. And what's 52 choose 2? 1,326. Okay, so we add at the top. What do you get when you add at the top? And you punch that in your calculator to see if it'll simplify, and it definitely will because they're both even. What do you get? Simplifies to 55, yeah, over 221.
Oh, my bad.
Okay, so there is your answer.